So when we were doing fractions, we learned about like and unlike fractions. So very quickly, let me revise that a little bit. So if we are talking about fractions, like fractions means the denominators are the same. For example, 3 upon 5, 4 upon 5, 1 upon 5, denominators are the same. So they are called like fractions. And unlike will be the opposite of that. If the denominators are not the same, then they will be unlike fractions. In that, what did we learn? That we can change unlike fractions to like fractions. Say, for example, 3 upon 5, 1 upon 3, they are unlike. But I can make them like. I can make the denominators the same by finding out the LCM of 5 and 3. I'll find out the LCM of the denominators. 5 will divide 5 once. It won't divide 3, so I bring it down as it is. Then 3 will divide 3 once. So my LCM will be the product of these prime factors. 5 3s are 15. Now, both of these denominators need to be changed to 15. 5 3s are 15. Whatever you do with the denominator, you do with the numerator. 3 5s are 15. Whatever you do with the denominator, you do it with the numerator. So, what will it become? 3 3s are 9. 5 3s are 15. 1 5s are 5. 3 5s are 15. Now, both of these unlike fractions have been changed to like fractions. So, in fractions, we already learned how to change from unlike to like, and the procedure was quite lengthy. You had to find out the LCM and do the multiplications, and finally you would get it. But when it comes to like unlike decimals, it is comparatively easy. Okay, so it's easy. And what is that? Before we learn about changing from unlike to like, let us first understand what is like and unlike decimals. Now, if there is a decimal, say for example 0.23, then there is another one 512.6, then there is one more 89.125. Say for example, there are these three decimal numbers. All of these numbers are unlike decimals because the number of decimal places is different in all the three numbers. In the first number, after the point, you have 1, 2 decimal places. Here you have, after the point, 1 place. Here after the point, you have 1, 2, 3 digits after the decimal. Therefore, they are called unlike decimals. So if I want to change unlike decimals to like decimals, I should have the same number of digits at the end of the, means after the point. Okay. So if here there's 2, here there's 1, and here there's 3. Obviously, I cannot make this one 2 or 1 digit. I cannot change the number. Now, even if we are changing from unlike to like decimals, we are not changing the value of the number. The number will still remain the same. It's only that the number of digits after the point will be the same in all the numbers. So, what I can do is, I can change these 2 digits to 3 digits because we have 3 digits here. So, I can make this 3 digits, I can make this 3 digits also after the point. So, what will I do? At the end of the decimal part, I will place a 0. Okay. Now I haven't changed the value of the number. The number is still 0.23 only, but it has 3 digits after the point. Similarly, here it is 1 digit. So I need to put 2 zeros here. Now I will have 3 digits after the point, and this one already has 3 digits. Now this and this, all the 3 numbers are called like decimals because the number of digits after the point is the same. Now at this stage, let me tell you one more thing. that whenever you place a 0 at the end of the decimal part, it has no value. Like for example, when we are talking about whole numbers, if I tell you, you have got 0.8 upon 10. Say for example, there's been a test and your teacher has written 0.8 upon 10. Does it mean you've got 80? No. What does it mean? You have scored 10. So the 0 before the whole number doesn't have any value. In the same way, similarly, if the 0 is put at the end of the decimal part, it doesn't have any value. Okay. So why do we need these like decimals? If the value is going to remain the same, why do we need them? The need is very similar to the need that we have in fractions. In fractions, when do we convert from unlike to like? When we are adding or we are subtracting, or when we want to compare. That is when we want to see if a fraction is greater than or less than, or when we order the fractions. That is, we put the fractions in ascending order or descending order, then we need to change them from unlike to like. So here also in decimals, whether you are adding decimals or subtracting or comparing or ordering them, you need to change them so that it becomes easy for you. Now what we are going to learn is how to compare the decimal. Say for example, you have 0.9 and the other number that you have is say 1. Okay. Now if you look at both of these numbers, some of you may think that, oh, 9 we have learned is a big number. That's why 9 is going to be the greater number. Okay. So now let me check. This is a whole number. The point will come after the whole number. Remember the decimal table? We have the whole number part and then the point and then the decimal part. Remember, here we have the 1, 10, 100 place, 10, 100, 1000, and here we have the point. Okay, and here we have ones, tens, hundreds. Okay, so this is 1, whole number 1. So obviously it will come here. So the point is after that. So what will this become? 1.0 and here it is 0.9. Now these are the numbers that are to be compared. Right? How will you compare decimal numbers? First you check the whole number. Here the whole number is 0. There the whole number is 1. And we know that 0 is less than 1. So this number is less than that. So though the 9 looks bigger than 1, it is not. So you don't have to get carried away by looking at the number like that. You have to check one digit at a time. Say for example, you have 0.2 and 0.02. So what is the meaning of 0.2? Now for you, this number looks small because it has only 0.2, but we have to change it into a like decimal. So here there are 2 places after the point. So here also I need to make it 2 places. So it will become 0.20 and then 0.02. Now we'll check one digit at a time. Whole number is 0, whole number is 0. We cannot compare. We go to the next 10th place. Is here we have 2, there we have a 0. So obviously 2 is greater than 0. So we straight away put the greater than sign. Okay. So that's how you compare numbers. So when the decimals are unlike, you change it to like. So it becomes easy for you to keep comparing one digit at a time.